Well, thanks first of all for the invitation and for the introduction. And I'm gonna shift a bit gear from what the previous presentation has been, that a lot of large focus on genetics. And here really about my talk will really not involve genetic almost at all. And the other one, the shift is really moving from the less common condition with common condition, and actually how large data and using several studies can help address some really public health issue. And talking about common condition and common exposure, I really want to talk about BMI, body mass index, obesity, so very common around the world, and as well mortality, one of the most common outcomes that we have. And what is the? I think we all know about the prevalence of obesity and overweight across the globe. So this is data from the Global Burden of Disease published in 2017, showing how actually the obesity, prevalence of obesity is quite high in many countries, especially Western countries, but as well in many other low-middle income countries, especially there's a growth in obesity and overweight as well in those countries. And according to WHO, there's about 650 million obese people when we define obese as a BMI above 30 kilogram per meter square. There's about 1.3 billion people, actually adults, are overweight. Doesn't mean that BMI between 25 and 30 kilogram per meter square. And one of the key questions that was around a few years ago, especially in 2013, was is there any link between mortality, between overweight and obesity in relation to excess mortality? And so this is just the two data that were, one guidelines and then one meta-analysis that were published in 2013. So the 2013 US guidelines, as well jointly by American Heart Association, American College of Cardiology, and as well the Obesity Society, suggesting that actually that overweight is not associated with excess mortality. And then the following up meta-analysis published in JAMA 2013, that as well with very similar conclusions, suggesting that actually why severe obesity is associated with higher mortality, both grade 1 obesity but overweight is not associated with overall mortality, actually suggesting that overweight was actually associated with lower all-cause mortality. So to try to address this question, what we've been done in the last few years, really putting together the global BMI mortality collaboration. That is a collaboration involving 239 prospective studies for about 10.6 million individuals, mainly across the globe. Like you can see from the map as well, however, you can see that the core are quite localized in few areas of the world, with some of the big areas quite not represented. And so you can see that there's the majority of data coming from North America and Europe, a little bit of East Asia, and then really limited data from South Asia and as well Australia and New Zealand. And the idea really was trying to use this data to address more reliably the association between obesity, overweight, and mortality, and really to try to disentangle what are the differences or potential similarity across different populations and across different subgroups. And so overall was about the overall data sets was about 50% female, 50% male. There's about 26% of current smokers. This is what about 50 the mean age in the population, and about a mean BMI of about 25 kilogram per meter square. And the idea was really how can we use this large data to address this problem using observational data more reliably. So what does it mean to address this? Really to try to reduce some of the bias usually come up in observational data. So a few steps were taken to try to reduce those. One was trying to exclude people with pre-existing disease, pre-existing chronic condition that we know there's an effect on BMI, so trying to limit reverse causation. The one limiting as well the initial limiting to the initial year follow-up, so excluding people in the first few years with events in the first few year follow-up, again to trying to limit in some way subclinical disease and reverse causation as well. And as well limited to never smoker, given that we know there's a big influence of smoking on BMI that actually can confound the association. So you can see on the flow chart how we came down from 10.6 million people to actually about 3.9 million people, but really selected people that are allowed to really assess reliably the association between BMI and mortality. And so actually you can see how now if you look at the association between BMI and the risk of mortality, I can see how the hazard ratio will change if you apply different exclusion criteria. So you can actually see from on the top end of the distribution of BMI how moving from people that are not excluded in blue to people when the exclusion criteria apply, how the hazard ratio change actually increasing from about 2 to about 3 in terms of hazard ratio. And the other way was at the lower end of the distribution, in which the hazard ratio for unexcluded people, in unselected people, was about 2 and going down to 1.5 when all the exclusion criteria are applied. So suggesting that, for example, many of the previous analyses that didn't apply all these criteria, sometimes due to as well the limited sample size, possibly were able to reliably assess the association between BMI and mortality. And so what was the association once we applied this criteria? So this is the association in male and female. So that suggesting actually that there's J-shaped relationship between both in male and female, but as well suggesting that the association is much stronger in male compared to female with an odds ratio of 1.51 in men versus 1.3 for women. And actually to address the specific question that was highlighted in the previous guidelines, people that are overweight, so in some way just above 2.5, and as well in 25, sorry, in men and women, there's actually an increase in risk of mortality. Possibly a small increase in risk, about 10% in risk, but actually compared to normal weight, there's an increase in risk even for people that are just overweight compared to normal weight. And actually there's no question about whether or not the grade 1 obesity or more severe obesity is associated with increased risk of mortality. So how can we as well use this data in some way that allow us to do subgroup and assess different information? So one of the questions was, is this association changing when we look at age? When we look, is the association between BMI and mortality similar across different age? And so here's analysis which we define 3 age groups. You can see actually how the association change and from younger to older individuals. Actually, the nadir of the association shifting from about 20 in the younger individuals to about possibly 24 in older individuals. So suggesting as well that there's potential differentiation between BMI and mortality according to different age. And the other question that I think was interesting to apply is this association as well similar across the globe and across different regions. So as I mentioned before, not every single region was represented, so really analysis was restricted to what we're able to cut across in terms of data that were collected. And here is, for example, data from Europe, North American, and East Asian, suggesting actually that there's quite a similar association between these 3 broadly defined global regions, so with Europe, North American, and East Asia. But when we move to South Asian core, partially, I think with the limitation, with the caveat that it's limited data, the association looks quite different, with a much shallower association at the higher end, and possibly a stronger association with the lower end of the distribution of BMI. And actually, this data were possibly later confirmed last year by publication from the Chennai study, actually suggesting that, again, very similar shape of association of what we show in the meta-analysis, suggesting that possibly this stronger association at the lower end of the distribution of BMI compared to the higher end of the distribution. So the other question was really about, is the association similar not only for all-cause mortality, but does it differ according to different causes of mortality? And so here's looking at 3 major causes of mortality: cancer, respiratory, and chronic heart disease. Again, suggesting that actually the association could be different, with a much shallower association for cancer, and possibly more U-shaped association with respiratory disease, and actually almost a linear association with chronic disease. Of course, one of the big concerns looking at observational data is how much in the respiratory cause actually smoking and the underreporting of smoking in observational data actually affect this kind of results for respiratory disease. So how can we then confirm this study? So this is a lot of this data I've just shown was really about the observational data with potential confounding, and despite we've been trying to reduce the confounding by different exclusion criteria, this is still possible to really have confounding effect in what we're looking at. And so what we've been doing with Stephen Murgess and other colleagues, we've been looking at how we can use genetic and especially Mendelian randomization to assess the shape of the association, in this case in UK Biobank. And actually you can see that the shape was pretty much similar to what been shown in observational study. And when this data was actually split between smokers and non-smokers, actually the association was even more linear for non-smoker compared to non-smoker, suggesting actually the inverse association at the lower end of the distribution is possibly due to a residual confounding effect in the observational study due to smoking that is possibly not as well as characterized in observational data. So just to summarize what been shown, I think despite the claim that was done previously in 2013, I think it's quite clear that overweight and obesity are associated with all-cause mortality in several global regions that have been studied, at least in our study, possibly with the exception of South Asia, in which possibly additional study are needed to try to clarify that relationship. I think it was interesting to show that actually there's difference in male and female, and as well at different ages, with actually higher risk in male and actually higher risk in in younger compared to older ages. I think that just the last point is really that I think that using large-scale data, using real pertinent data, even for common outcome and common exposure, can actually help to provide very insightful information, especially in terms of public health impact and public health information about the relationship between exposure and disease. And just want to thank everybody that have been contributed to this work. This has been a collaboration between more than 250 institutions for 500 investigators. It's been, despite the limited resources, been an incredible effort, incredible journey to produce this kind of results. Thanks.
Time for one question.
Yep.
So, in South Asian countries, like in India, the obesity in form of waist-to-hip ratio, abdominal obesity is much more important than the BMI. So even in our study on the breast cancer, on the 3,000 cases in controls, the waist-to-hip ratio, which measures the abdominal obesity, was found to be more important than the BMI. And even in the Barshi cohort that we are doing, again, the waist-to-hip ratio is more important. So even if you have the lower BMI, the abdominal obesity is much higher. So I think for obesity, waist-to-hip ratio has to be measured to take the data on obesity.
Yeah, so BMI is a very crude measure of obesity and actually fat distribution, but actually has the beauty of simplicity and actually the beauty of being recorded across different studies in different regions. But I completely agree that looking at other form of fat distribution could possibly inform other sort of link between obesity and fat distribution and disease. Question?
I want to second that comment. In a large cohort in northern Iran, we recently observed that there was barely any association between BMI and mortality after 7,000 deaths. But when we put in waist-to-hip ratio, it showed a very strong signal. And particularly when we put waist and hip both in the model, adjusted for each other, there was a huge risk. There was a huge hazard ratios, whereas we didn't see it with BMI.
Well, again, suggesting that possibly fat distribution it's better captured by waist depression, especially in those populations.
Thank you very much.